Hey, welcome back. In previous lectures, we've seen that we have to sort of pass in the size of the array to a function if we want to operate on that array within a function. And we typically do that by declaring a constant integer for the size of the array, and then we pass that in for the size. But of course, the issue with that is if we want to change the number of elements, so if we want to add an element to an array, then we have to go and update the constant integer, the array size integer. Otherwise, not all of the elements will print out in the function, for example. Whatever the operations are that we perform on that array using the constant array size. So as an exercise, just to start off with, I want you to try and calculate the size of an array. And this is really what we are going to discuss in this lecture, but I want you to try this by yourself before we continue. As a hint, remember that we can calculate the size of an array or the size of an element with the size of operator. Alright, so go ahead and try that now. There's actually a function that we can use for this as well, but I want you to try and calculate this. So go ahead, try that now, pause the video, and when I come back, I'll show you my solution. Okay, so in this example, I have a simple function print array, and this is going to take in some array of characters, and that is going to be const, so we do not want to modify the elements in the array. And then we'll also pass in the size. This is going to print out the elements in the array R, and then it's going to do in a for loop. It is simply going to print out those elements. Okay, so in the main function, I have a constant array size again. I initialize that to 4. And then I have this, an array of characters. I pass in the array size, of course, and then I go and initialize that. I just pass in any characters here, X, Y, Z. And then I also have the null character just for out of interest in here as well. So that is basically a C string now. We can get the size of the array. So I do size of, and I pass in the array identifier. Then I can also get the size of an element within the array. So I do size of. Now I do array. I have the subscript operator. And then I get some element, so I want to return some element within the array, doesn't matter which one, so I'm just going to return and work with the first element, so I pass in 0, that's going to be fine. It's going to return that particular element, in this case it's going to be a char, so this is going to give us the size of a char, and then here I print out the number of elements in the array is. I continue printing out, I just broke up this line because it's a bit long. This is the calculation that I'm doing to calculate that, so I get the size of the array, passing the identifier of the array divided by the size of what a particular element is. So if the size of array, if you think about this for a second, what will the size of a character array be with these 4 characters in them? Okay, then a particular character, one character is going to be 1 byte. So 4 divided by 1 is going to give us 4, and that is how many elements we have in the array. We have 4 elements in that array, and then I just go and print this out. So I pass in the identifier of the character array, and then I also pass in the array size. Build and run that, and you can see the size of the array is 4. The size of an element in the array is 1. The number of elements in the array is 4 then. Again, 4 divided by 1 is going to be 4. The elements in the array is going to be X, Y, Z, and we also have the null character, but that's not going to print here. Then we get end of program. I chose an array of characters deliberately here because I'm going to change this now to an int, an array of integers. Now you will see we get this error here. The argument of type pointer to int is incompatible with parameter type, pointer to char to const, so pointer to a character constant. So this is where it is important to, and another example of where it is useful to create more generalized functions with templates. For example, I can change this here to an int, and this will now work fine. Build and run this. Now the size of the array is 16, remember we have 4 elements in there. The size of an element here is 4, so 4 times 4 is going to give us 16. So the number of elements in the array is 4. And look at what this prints out. The elements in the array is, the elements in the array are 120, 121, 122, and 0. Remember 0 is the null character in the ASCII table. 120 is the ASCII code for the character X, the lowercase x. If you don't remember this, you can always look it up in the ASCII table. Also, if you don't understand why it is that we get those integer values, you may want to pause the video for a second and think about that. Alright, let's look at what we have. We have this array, an array of integers, but we have characters in there. Now, of course, those are going to get converted to integers implicitly. We pass in that array. This function is going to accept an array of integers, okay, and that is going to be const, so the elements will not be able to change the elements in here, but the point is that is an array of integers, so we print out integers, not characters. Also, as I mentioned, We can create a more generalized print array function here by templating it. And then this will work for both characters and integers or whatever other type we have. So it's now going to work for integers. And then I can change this back to characters. Build and run again. And you can see that is now characters. We get X, Y, and Z printed out. So in C++17 we have the std_size function. So instead of doing this right here, this calculation, what we can do instead is and I'll clean up a bit. So we have this size function and I'll pass in the array, just the identifier for that. We don't want to get an element or anything. We just want the size for the array. That is the number of elements in the array. This again being a character array, the number of elements in the array is 4. So we get size of the array is 4, the elements, the size of an element in the array is 1, and the number of elements in the array is 4. And then we go and print those out again. Now what this means is we can simply use that function wherever we want the size of the array. So we can go and get rid of this now, if we want to do that. And the reason why we may want to do that is, let's say we go and add another element in here. Okay, as we develop, now we have too many initializer values in here. We have too many elements. The array can only take 4 elements. So to get rid of that issue, we are going to remove that constant. And now I can go and add as many elements as I want. And now what I can do is I can pass in the size of that, because remember this print array function now expects the size of the array as well. Okay, so I'll scroll down and we can do the same thing that we do right here. We invoke the size function, we pass in that array. That is going to get the size for us and we don't have any issues with that. Build and run. And we get those elements printed out. And we get a warning here, conversion from size t to int, possible loss of data. Now what is that size t that we get here? I'll just scroll back up. That is, I'll just change this here to this type size_t. Now that is basically an unsigned long in this case, so I'll just do Ctrl+K, Ctrl+I, and you can see this is a typedef unsigned long. The name for that type is size_t, and of course it makes sense for this parameter to be unsigned, whether it's an unsigned int or an unsigned long, because we're not going to pass in a negative size for the number of elements within the array. So it makes sense for this to be unsigned. So in that case, it's fine. You can use size_t, and with that you can pass in large sizes of arrays. So wherever you are using some sort of a size, where it makes sense for that to be unsigned, okay, the size of some container, it cannot be negative. It can be 0, so it can have 0 elements in it, but you're not going to have -5 elements in it. Okay, so in that case, where you have that, you can use the size_t, and if I build and run, that warning will go away. The size t could also be unsigned int, so it's going to depend on the system, but on my system here it is unsigned long. You can see this works fine now. It expects this here, so if you don't pass that in, the size of it, then of course this function is not gonna work. It's gonna give us an error. But with that, we are eliminating the need for us to have that constant where we had to pass that size in right here. Okay, so here I have v, let's say I do v, but now I want w, of course. I can just go and add that character, v, w, x, y, z, and I can build and run, and this will work fine now. And we don't have to change some constant for the size. The size is going to be deduced at compile time. As a quick summary, we can determine the size of an array by doing this calculation, size of the array, and we can divide that by the size of a particular element within the array. We can also use the std_size function from C++17. I would like to note that you should check within the project settings and make sure to set that to C++17 or higher. Okay, we'll move on to a bonus section now before we wrap up this lecture. This section is going to be a bonus section for you. Since we have covered all of this information up until this point, you might think, well, how can I get rid of the second parameter? Maybe there's something that I can do with the template, for example, or something like that. So we will look at that in this example. Now to get started, remember that we can also loop through an array using the for loop, and you can do the same thing with a character array. For example, instead of calling this function, what I'll do is I'll type out 4, and then I'll press tab, and then I'll see by default we actually get the size underscore t, which I typically replace with an int, as you can see up here. I typically have an int there, but of course for the most part that is not how you use. We typically count up to a certain value, or we count down to 0, and then that is where the loop is going to end. We don't typically have negative values. Now because of that you can use an unsigned int, or you can use the size t that I mentioned before. But in any case, let's go and use, instead of doing this, we are going to use a for each. We'll do auto. For each alphabet character within that array, I want to print this, I want to do this, I want to print it out. For each alphabet character in that array, I want to print out that alphabet character. Build and run, and that basically works as before. Okay, so we are familiar with this sort of syntax, the for each at this point. So I'll just cut that out, uncomment this function invocation. So we'll call this function again. But what I want to do instead is I want to make this a for each now. When we do this, we'll actually get an error, a strange error, which I'll show you how to fix in this section. For each element in that array parameter, because we are not assuming with a generalized function that we are passing in characters, those can be integers as well and so on. So for every element we want to print that element out. But if I try and build this, we'll get a bunch of strange errors, such as begin, no matching overload function found. So now I'll comment that out and I'll make sure that this is a char. And if I try and build now, we'll get this sort of error here. This is the type of error that I wanted to show you. This range-based for statement requires a suitable begin function, and none was found. And you have to think about what this means here for a second. I'll just copy that and I'll comment this out for a second so we don't get any errors. Okay, let's say I want to declare some array like this. We'll get some incomplete type is not allowed, because of course we have to pass in the size of that array. If I build this, we'll get that sort of error. The array is unknown size. So I'll just undo a couple of times so I get my function invocation back. Maybe comment this out, and then I'll go and change the type here to something like int. Now of course we are passing in an array of characters at the moment, so we'll get another error here. And pay attention to what we get here. An argument of type pointer to char is incompatible with parameter of type pointer to integer constant. Okay, so that is basically what we have here. We have pointer to integer constant, and actually I can remove this. So this parameter, this array parameter, is now a pointer to an integer constant. Just to get that for loop back again so we can print all of those elements out. Remember that we can use the subscript operator with a pointer. And so if I build a run, and I'll have to change this actually to a char before I build a run. So build a run, and that will now work fine. That will print those elements out. But of course the reason why we have this sort of syntax is to make it easy to read. So if you go down here and you do Control spacebar to see the prototype for that, we see the return type and everything, and then we see what it expects, what it takes in. It is going to expect the size of that some array, and it's also going to take in the array. And of course the array identifier by itself is going to give us a pointer, as we've seen before. Okay, so that's fine, but how can we now get this function, this for each to work within this? Well, what we actually need, because we've seen that the parameter is not what we expect, even though the syntax says it's an array, it's actually a pointer to a char constant now. And let me go down here. Basically we can do this. Okay, so we've seen that before, but of course the array identifier is basically a constant, so we cannot assign something else to that, some other address to that, as we've also discussed. Now you might already be thinking, can't we do some sort of a reference instead of a pointer? Because a reference, of course, is going to be an alias, so we want an alias for that array instead of a pointer to the first element. Because a pointer like this, it can be a pointer to the first element, it can be a pointer to the second element, and so on, but it is not an alias for the entire array. We've discussed the fact that it's only a pointer to the first element in the array. Okay, it does not represent the entire array. So what we can do is, we can actually create a reference to that array. And with this we need the size, so we'll just pass in that size again. If you have the constant, you can pass that in, or you can calculate it in this way. And now what we also need is the name or alias for that array. For simplicity, I'll just call that array alias. Okay, and if you try and do something like this down there, go and do something like this. Try and print every one of those out. Comment that invocation out. Once more, notice the difference. This is just a pointer to the first element of the array. Whatever we assign to it, we can assign any character to that. That is not an alias for the array, it's just a pointer to it. Then you have a reference or an actual alias for that array. The array here that I just called R. So we want to use this alias instead. And if I build a run now, that should work fine. Yeah, you can see that works fine now. We don't get any warnings or errors. Okay, so we have an example of the difference between a pointer to an array and an array alias or reference. And I'll actually just comment that out here before we move on. And I'll uncomment this function invocation. And then I'll go and move up. And I'll uncomment that template now. And we actually want to pass in the size as well. So how can we do that? This is another step that we can do. We make this print array function more generalized. It's going to be a template now. It's going to expect a type. And it's going to expect a size, so non-type parameter of type size t, so that's going to be again an unsigned long in this example. And let's just call that array size p, and I'll paste that in here. Then I don't have to pass in the size as an argument to the function. So the function is not going to expect an argument, an actual argument for the size anymore. It is now going to expect the size as a non-type argument. And I can make this more generalized, so I pass in that. Then I have t here for the type instead of char. But again, think about it for a second. This is now going to be a pointer to some type const, and we pass in the size. But we want this formal parameter to be a reference or an alias to whatever argument, array argument that we pass in. Okay, now think about this for a second. This is not going to work because this is now going to be an array. If you think in terms of precedence, that is also how we are going to read this. This is going to be an array. The subscript operator, these brackets, are going to have preference over this ampersand operator. So this is going to be an array of references to some type constant, and that is not what we want. That is actually illegal. We will get an array of references is not allowed. So because of that, of course, we are going to use the parentheses. This array is now going to be a reference to whatever we pass in. We want the type and the size to match. And let's just go and build and run this before we look at the loop again, just to make sure this works. And I'll scroll down actually here, because we have to remember to remove what we pass in. We no longer have to pass in the size. That error should go away. And actually, if I do Ctrl+Shift spacebar, you will see we now get that template, pass in t, array size p for the size of the array. Right. Build and run. And we'll get an error here. We have to change one more thing, and that is the size p here. And that is because I went ahead and I modified the name of that, which was why I got that error in the first place. Otherwise, you may not have gotten that error. If I build and run, that will now work as before. And I'll uncomment this, and I'll comment this line out now. We should be able to use the for each loop just fine, because the array is now an alias. That is, the array parameter is now an alias for whatever we pass in. It is not just some pointer. Build and run, and you can see that works fine. And what's great, we don't have to keep track of the size, so I can add more characters in here if you want. I can remove characters. I don't have to keep track of the size with some constant, pass that in everywhere, change it constantly whenever I want to add some elements in here. And I actually don't have to pass in the size even within the function. So the function no longer has to expect some size that is going to be deduced. Now, of course, you can go and pass that in. So just for clarity, you can pass in char, for example. And we can do this size thing that we do here. Build a run, and that will work fine. Okay, so I'll just have both of these here, just so you can see which one. Both of these will work just fine. And then also, if I change the type of this array to an array of integers now, I don't have to go and change type arguments or anything like I have to do with this one, because here we'll get an error now because we're explicit with the char. And of course, that is because this array is no longer going to match that type. So I'll just comment this out. So with this, we can have really generalized abstract functions, and with the deductions that the compiler will do behind the scenes, it is going to deduce the type and the size. So with that, you don't have to go down in a huge file to go and make changes everywhere later on if you decide to change your type of your array or the size of it, as we had to do before. But of course, this here is going to work regardless. But as we can see, it's going to deduce both the type and the size. So I'll just build and run one more time, and you can see that works fine. It's going to convert those to int implicitly now, and we get the sizes and everything printed out. So I know that was a bit of a long one. I felt that this was a good place to introduce it since we discussed templates and everything up until this point. I would like to mention that this is not typically how you would go about it. In modern C++, you will use some container such as a vector or an array from the standard template library, but we'll discuss those in a future lesson. That is going to be a big lesson, but you may see this in some code and you may want to use this for yourself. So just a few things to get used to. The syntax right here. We want a reference to or an alias for an array, not some array of references. So we need to use those parentheses. And then as we've seen with the type deduction, we no longer have to pass in everything, all of the sizes and everything, keep track of all of that stuff. Before we wrap up this lecture, just to drive this idea home, I'll go and copy this again. And I'll go and make sure that this array is an array of characters again. Okay, so we now have a pointer to an array, ptr, so I pass in ptr now, and now we'll get some sort of error. So let me go and specify the type and pass in the size explicitly, and we'll still get an error. And so let me go and build this. Cannot convert argument 1 from a pointer to char to this type here. Can you get the same thing down here? Cannot convert from pointer to char to this particular type. And notice also that the type here is displayed, so t is char with the template. And then also pay attention to the fact that the size of the array is specified in that type. So the point of this demonstration is that the compiler sees these as different types. You have a pointer to a char, and then you have this particular type. Some type, in this example a char, to a constant, and that is going to be a reference to an array. So I just wanted to emphasize that we have the difference between the types. And then also, even if I go and change the size, so I have a different size, but I pass in the correct array. So even when I pass in the correct array and I build now, we will still get an error because we cannot convert from argument 1, which is a char array of 6 elements, to some array that has 8 elements, and the same basically here. Cannot convert from this type to this type. So for the compiler, these are different types because the sizes of those arrays differ. And of course, if you go and remove the const, that is not going to make a difference. So if I build again, you will still get that error. But if the size matches, then that will be fine. I can build a run and that will work fine. Alright, so again, I just wanted to emphasize that the compiler sees those as different types. To wrap up just a summary for you, we can declare a pointer to an array by declaring a pointer and assigning the identifier of the array to that pointer. The identifier of the array is going to point to the first element in the array as discussed before, so that is going to be assigned to the pointer. But we can also declare a reference or an alias to the array. We need to pass in the array size, and we also need to make sure that we don't have an array of references, which is going to be illegal. And because of that, we use parentheses, and we prefix that alias name with the ampersand between parentheses, and we assign that also by using the array identifier. Okay, so I hope this bonus section and this lecture was useful to you, interesting to you, and I'll see you next time.